I'll talk a little bit about the technology that's important to us coming in the future for exploitation of the Arctic. This actually presentation was given at a Norway session here early last year. I had to go to one that was off the shelf because we do have a process for getting new presentations, and it is going to take us too long. Anyway, what I'll do today is just talk a little bit about the Arctic, its environment, and its cost challenges. It's a big area, it's high cost. What are some of the key technology advances that have helped us along the road in the last 20 years? Some of the current technology focus areas and some areas for future collaboration. I'm going to focus mostly on the offshore in this particular presentation, but I can speak to the onshore as well. The Arctic contains about 22% of the undiscovered petroleum resources of the world, according to the U.S. Geological Survey. Development in the Arctic faces significant technology challenges. Capital costs can be significantly higher than in the south. We have seasonal limits on exploration and development. We basically normally have a 3-month season, whether we're working onshore or off, to go to work. And it's a fragile environment, and it requires the highest level of HSE stewardship. So there's an opportunity to use new technology to improve efficiency and reduce costs. Again, in terms of the challenges, this is again offshore, ice structure, ice seabed interaction, narrow weather windows, logistics and transportation. We're in remote areas. Always the need for new infrastructure. It's a sensitive marine environment when you get in the Arctic, and of course safety. The pictures that you're seeing there, these are from over here. From the 1980s, the Moloch bottom found a structure in sea ice, the Culloch. This is with Gulf, the predecessor of Conoco Phillips. The ice in the Arctic normally in the order of 2 meters or less thick, but when you have big lumps come through, you can be dealing with 30 meters or 40 meters of ice. And these are that's the sea bottom, images of the sea bottom. It can travel as a keel, it can bend, it can curve, it can be a comb. So there's some significant environmental issues when you're in that area. The big issue for the Arctic is really cost. And just to explain that a little bit, if you take a look at a southern project, you may not be able to read this, but in the yellow box, I've outlined the main steps to lead to a project in the south for an oil and gas project. Your seismic, you do exploration drilling, delineation drilling. There's some needs for expansion of logistics and infrastructure. You design it, you build it, you do your development drilling. You need some kind of an offtake solution, whether it's pipeline or marine, tankers. You operate it for 20, 30 years, and ultimately you abandon it, and you put a circle around that, put some prices on it and volumes, and you have your economics. When you move into the north, you have all of those same things. And you have what I refer to as Arctic cost factors or Arctic cost multipliers. And they are significant. Narrow weather windows, the need for the logistics and transportation issues, labor productivity, the need for new infrastructure, ice forces, cold temperatures, weather downtime. You've got to protect the permafrost. It goes on and on. Waste management is a huge issue when you go to the north. And the net result of that Arctic cost factor, that's not an exaggeration in terms of the height. If you drill a well in west central Alberta that costs $5 or $6 million, it's 25 to 30 million when you go to the Mackenzie Delta. If you build a pipeline in western Alberta or in Alberta, it might be $50,000 a diameter inch mile. It'd be 300,000 or more per diameter inch mile when you move up there. So there's significance. Now the point of this chart here that I just want to mention to you, that the good news is what my job is about is looking for opportunities to bring costs down. All of the conventional areas of the oil and gas business are in this box. You bring costs down here, the multipliers come down. So we spend a lot of time focusing on conventional technology, and I'll talk more about that in a second here. The other opportunity is to focus your technology effort on the Arctic specific factors. If you can bring some of the logistics or transportation or weather window issues down, that's another approach to it, and we use both. So again, costs can be a lot higher, and the factors, they do vary from onshore to offshore. These are some of the technology advances that many in the room will be familiar with over the last 20 years, and they really moved us a long way in terms of what we're capable of doing in the Arctic. These are things that basically, most of them go into the yellow boxes, but when you think about it, digital computer processing and modeling technology since the 80s, it's just an enormous change. Digital communications, satellite, fiber optics. These are all tools we are using now. 3D and now 4D seismic, extended reach drilling, very important in the Arctic. In the Arctic, it's about reducing quantities, reducing manpower if you want to bring costs down. Half of everything you do is manpower. And when you move that manpower to the north, it costs us three times per man hour the cost of having it done in Edmonton, Alberta. Directional drilling, horizontal drilling, these are all used in Western Canada. Many of them are developed in Western Canada. They add huge value. To the extent you can improve them, it'll add value for the north, and the multiplier is there. It's significant. Many other drilling innovations. I'm not going to read all of these. Coiled tubing, underbalance, casing drilling, new advances in mud, logging and measuring while drilling. Downhole sensing is a significant opportunity going forward. Expandable tubulars, drilling for the north, not so much in the south here, but drilling, cutting, disposal. We now grind and inject mud up in Alaska. We don't put it in pits anymore.